here is something that you guys dealt with in biology and should have seen, something similar to these. I know it's been a while, but within biology, you guys talk a lot about structures. And those structures are DNA, right? You guys talk about DNA. And RNA and proteins and fats. And carbohydrates and different things like that. And those are all molecules. And if you look up here, this is the base of an amino acid, which is the base of proteins. And so all amino acids have this structure right here that's on the board. If you notice, carbon is central to that structure. And when you guys study, or if we would study organic chemistry is carbon-based. And basically you look at a lot of different structures that have carbon as the central, we call the central atom. And if you notice, here's carbon. This is the central one. Branched off of that is just called an amine group. So NH2 is called an amine group. Yep. And then this is called a carboxylic acid because the reason it's an acid is that this H here can be easily taken away. And that's how it kind of bonds together. So what happens in an amino acid, the H is taken away here, and then an O is taken away from another, an OH is taken away from another compound and it makes water. So you'll get a bunch of these hooked together to form a row of structures. Okay? So why am I telling you this? Chemistry is really important in biology. So if you're saying, I'm not very good in chemistry, but I want to do some things in biology, if you notice, for example, this picture here, if it comes up from my, actually, I don't know if I can get it be any larger on that.
And plus. Yeah, just
We make something else. Maybe I make it smaller. Okay. But I don't know if you can see it or not. You can't see it. But these are all the different amino acids. Adenine, thymine, cytosine. You guys heard of those, right? Okay. And they kind of go together to make your proteins. So what we're going to do is start off really, really simple today and get you kind of the basic understanding of how to put together what's called a Lewis dot structure. If you look at the bottom of page 280, guys, look at the bottom of page 280. Do you guys kind of understand how those dot structures or Lewis dot symbols? Yep. So you guys kind of understand how those came about and how you can find them? Okay, so let's just do that real quick for those who need a little bit of review. So if I write, for example, phosphorus. How many dots does phosphorus have? 5. And they go like this. 1, 2, 3, 4, 5. Okay, but you don't have to do it that way. You just have to know it's 5. That's fine. Okay, boron. How many does it have? 3. Okay. Iodine. 7. Okay. So these pairs we know they're full orbitals, right? Did you remember that? And then this dot represents an orbital with 1 electron in it, correct? Okay. And then phosphorus has, what sublevel is this, do you think? S. And these are P's. Good. So those are the P's. Questions?
Shouldn't you have to fill the S before you go to the P's for boron?
For which one?
For boron?
Yeah, boron probably should be written like this. Yep.
So which way do you want us to write?
Well, that becomes a little bit of a question mark because in AP chemistry, once we get to it, we'll realize that boron doesn't have to have 8 electrons around it. It can only have 6 and still be stable. And we're not going to do those exceptions in this class. So in their class, they would write it like this. So here's what I'm saying is that the main thing is knowing how many electrons it has. That's the main thing. Okay? Because when we use this method to put these structures together, we just have to know how many electrons they have. So what we're going to do, if you guys remember back they had those lines that represent covalent bonds, we're going to start out representing covalent bonds with dots. That's what we're going to do. So there's 5 steps. Go ahead and write the first step, and then we'll give you a formula so that you can do the first step. So you're going to do the first step. So here's the formula that you guys are going to write down. Okay? So we're going to put all those elements together in one structure or one unit, and we're going to eventually call that unit a molecule. So we've talked about ionic compounds, and ionic compounds don't form molecules. There's only what's forming a molecule is when we put atoms together where they share electrons. Ionic, they don't share electrons, they transfer electrons. So now we're switching gears from naming and writing formulas for ionic to doing molecules, which is 2 or more atoms hooked together with covalent bonds. And a molecule is a single unit that's a representation of a molecular formula. So, you guys wrote those all out, right, separately? And nitrogen would have shown like this. Your 2 hydrogens would have been here. And then your fluorine would have shown 7. Is that what you guys have? Okay. So, first step, after some students do 2 or 3 of these examples, they don't do the first step, and all they do is count up all the electrons. So for nitrogen, they'll say, that has 5 electrons. And for fluorine, it has 7 electrons. And for hydrogen, there's a total of 2 electrons, 1 each. So I add those all up, and I get 14. If I count all these dots up, I get 14. So sometimes students will just know how many they count across, and that represents how many valence electrons we have. So these are valence electrons that are involved in bonding between each other. Okay? So your next step, okay, you don't have to do this because I'm just going to show each step and what we had on the previous step so that you guys don't have to. Okay, so the next one, it says decide the central atom in the structure by seeing which atom needs more electrons to get an octet. So which one needs the most to get an octet?
Hydrogen.
Okay, so then that's, when we first go through this, that's the reply. Here's hydrogen's electron configuration. Here's fluorine's electron configuration. Or orbital notation. I'm going to show orbital because that's what we're looking at. And then here's nitrogen's. You guys don't have to show this because you guys know how to do this already. Okay.
Where's that word that you get in?
Octet. Alright. So now looking at this again, how many electrons can hydrogen get? 1. It can only accept 1, and then it has a full level. So hydrogen can never have an octet. Does that make sense? Hydrogen can't have an octet. So according to this statement, you got to exclude hydrogen from your choice. Has to be nitrogen. It needs 3. Fluorine needs 1. So we're going to decide the central atom, which one needs the most. And so nitrogen will go in the middle of our structure once we write it out. Okay? So I'll come back to that. So we need to figure out how many electrons total. So how many electrons total do we have? 14 electrons. Okay. So that's going to become key throughout the whole process of putting this together. Okay? So then the next step. Did you get that all written down, step 2?
Yeah.
No.
Oh.
Nope? Okay, we'll go back to that.
Place this in.
Thank you.
Again, you don't have to write out the orbital notations, okay? So, as they're writing that out, I'm going to go ahead and state 3. And 3 is basically saying this. When you put your structure together, what you're going to do is you're going to put your symbol, the central element, in the center of your molecule, or your structure, and then you're going to surround it by all the other elements. So what you're going to do is you're going to put nitrogen in the center, and you're going to surround nitrogen by all the other symbols present. Okay, and you want to put them around at 90 degrees. So at 12 o'clock, 3 o'clock, 6, and 9. So that we're all kind of doing it the same way. Now, you can do it at different angles if you want to. That's up to you. But so that we're all seeing the same structure, and it makes sense. If you do it that way to begin with, it'll make it easy when I have to give answers. So we know nitrogen's in the middle, and we know hydrogen. We have 2 hydrogens and a fluorine surrounding it. Now, I want to tell you that if you want to write it like this, you can. All I ask you to do is that when you write it around, nitrogen's in the center, and then all the other atoms are surrounding it at 90 degrees. So it can be written a bunch of different ways, because we know this structure will eventually become 3-dimensional, and it doesn't really matter how you position those elements, because those molecules can rotate and move through space. What's the other thing that you're required to do in step 3?
Place 1 pair of electrons between the central atom and...
Right, you just decide, hey, I'm going to put a pair of electrons to show that there is a connection, there is a bonding between that central atom and each of the branched atoms. So those ones on the outside are called branched atoms. And so I started out with 14 electrons. I'm going to do what's called an accounting method of electrons, and I can't use more than 14, and I can't use less than 14 in my final structure. My final structure is limited to how many electrons I start out with. So I start out with 14, and I've used 6 electrons. So I'm now down to 8 electrons that I can show. Any questions on that step?
Each branch atom.
Which one's the word? Which one are you wondering about a word?
Each.
The central atom and each branched atom.
Okay. I was confused.
Okay?
I wrote down. I didn't think about it. You just wrote it.
Any thoughts? Now, I want to tell you now that we'll have students that will make up their own rules and they won't follow the steps. And because of that, they're going to get, especially at the beginning, they're going to start getting a bunch wrong. So, last period, we had people not even following the steps, and deciding that they were just going to do their own structure, and then they had questions right away. And I said, well, are you using your notes as your steps? And, oh, no, I'm not. So eventually you don't have to use this. Eventually you'll have it down. It'll be memorized. You'll know it. So, questions on that? So then the whole goal is for everything to have an octet of electrons. So which elements are not fulfilling that goal? Which ones?
H.
But H doesn't need an octet. So H actually is fulfilling its goal because it has a full outer shell of electrons. So H is actually fulfilling that role, even though we don't say it's an octet of electrons. We know it has a full level. So what the octet means is a full level. Nitrogen doesn't have it, and fluorine doesn't have it. They have to have 8. They have to have 8. Okay?
Do I need 2 more?
Okay, just wait, because then the next one will tell you where you need to put these next set of electrons. So we have 8 to work with, or 4 pairs. So we're going to have to determine where they go. They're either going to go off of nitrogen or off of fluorine, right?
Yeah.
So the way to do this, you want to give the branched atoms get those electrons before the central atom gets it. So if those electrons have a choice, they're going to go to the branched atom before they go to the central atom. Okay? And that's what the next step will say, that you'll need to place pairs of electrons around the branched atoms so that they can have an octet of electrons. You're going to place them around the branched atoms so that they can have an octet of electrons. So go ahead and place it around. So how many did you use up of the 8?
All.
Right?
Well, for the branch atoms, but then can't you use the
Right.
too?
Well, eventually we'll get to nitrogen.
Oh, okay.
Okay? Because sometimes what will happen tomorrow, you'll use them all up and the central atom won't have 8. In this case, it's going to get 8, and all the problems we're going to do today, they're going to have 8. Everything works out perfect when it comes to what we're doing today. So we take away 6 electrons, we're left with 2 electrons.
What is that? Is that an 8? That's like
That's just like what I had earlier. Yep. Okay. So now tomorrow we'll add a couple steps to 5. So the next step is, of course, nitrogen needs its 2. So the next step says, if there's any left over, the central atom gets it. So if there's anything remaining, in this case 2, the central atom can get it now. Okay? So that's...
Hold on. Can you move over a little bit?
Some of this, guys, I'm repetitive. Okay? Meaning I had it on a initial slide, and I'm just rewriting it so that you guys can see the progression. Okay? That central atom gets 2 electrons or pairs. So those 2 electrons go right here. And so anything left over, 2 electrons in this example, will go off the central atom. Now, I have this labeled Lewis dot structure, and that's because I just showed dots for all the bonds and all the... These are called lone pairs. The ones I have circled here, these are called lone pairs. They're alone. Okay? This here, these are called shared pairs. So how many shared pairs do we have? 3. Okay, how many lone pairs do we have? 4. That adds up to 7 pairs, which is 14 electrons. Now, what happens is, do you guys remember those structures I showed you earlier? Where we had an amine group and it had this look to it. Remember that? You can see why what these lines represent now. The lines represents a single covalent bond or single pair being shared.
So what does the 2 lines mean?
The 2 lines are tomorrow. They're called double bonds. And you can have triple bonds. Okay? Now, carbons can make long chains, and then so that's why when we talk about compounds, 95% of all the compounds are molecular. Because they can just be arranged in a whole different combinations with different lengths, different branches, and that's where it gets really, really complex when we get into biochemistry and organic chemistry, because we've got these structures. In fact, the state of Nebraska have to make up new laws every year when it comes to drug enforcement, because the people that make the synthetic drugs, what they'll do is they'll change a branch on the drug, and it doesn't really affect the drug's what it can do. And because of that, changing one little thing on the drug, the synthetic drug, now it's legal. Technically legal. Does that make sense? So then what they have to do, they say, well, we're going to come up with a new name for this new drug, and now it's illegal. So that when the crime lab tests it, they come up with that drug, they can match it up as being illegal. Okay? But they're always looking to make up synthetic drugs where they'll change somehow. They're smart. Okay? Where they can change it just a little bit, and it makes it an illegal drug into a legal drug until they make that decision of how to make it illegal again. Okay? So, we're going to have you guys practice these 5 examples. So write those down, and
Are we turning these in, or is this?
I will look at them.
Back.
Guys, everything I do, for the most part, is covered on page 282 and 283. So you have 2 sources. You have notes, and you have page 282 and 283. They go through the same exact setup.
We don't have, this can be on the same page as the notes, right? We don't have to go separate.
No, don't have to turn it in. Okay. Now, if you notice, these first 3 across are neutral. They don't have a charge. Okay? These next 2 here have a plus and a minus. Okay? The plus means what? Yep. 1 less electron. So you're going to come up with a total, and you're going to have to subtract 1 from that total. It'll be 1 less. If it has a negative 1, then what's happened? Has an extra electron. So you'll add an electron to your total when you start using your total to determine how many pairs of electrons you're going to have. Okay, so do each one of those, show the dot structure and the structural formula. Alright?